In this lesson, we still have quite a long journey to go on before we've got anything that's, we could consider even halfway workable. So the first thing I need to start doing is I need to start tidying up some of these files. The first problem we have is that we've got a bit of hard coding, and I don't like hard coding. So we need to, if you remember, we're sending in S, A, or Q. That's okay for a comment, but it's probably not very good for the soul. So let's put a few constants in here to mark that we don't want to see an A being used through the program. We would like to see a string which means something. So for an annual bond, annual type will be A bond semi-annual type will be equal to S, and we can have bond quarterly type equal to Q. That makes me feel better. The other problem is, do we ever have a bond that's a standard bond? I mean, if we go to the main program, we see we've got the basic bond. Is there any bond which is basic? 1 year to go, 10%? I don't think so. So what we'll do is we won't bother with a basic bond. We'll only ever go for a kind of complicated bond. When I say complicated, I just mean, we define 1,000 principal, 10% rate, 10-year maturity, and it's semi-annual. That works for me. Now, I don't need all this, I don't think I need all this stuff here. I think we can just clean this up a bit. We do need the price though, so later on we'll return a price. I've broken this probably in many ways. Oh, yes, of course. I don't have a basic bond type anymore. So let's just get rid of that, and get rid of that. Okay, we're okay so far. Anything else wrong in this header file? There is a certain problem we have, and the problem is this. So far I've kept it simple by just having rate. But that's ambiguous, isn't it? Do I mean market rate? Do I need coupon rate? Do I need fixed rate? Do I mean, what do I mean there? Well, I should have defined this earlier. Now, do I throw away all this code and don't cry to mummy? No, I just change things around and just make my definitions a bit more specific. So I'm not just going to have a bond which has a rate coming in. When the bond, I can destroy this now. I just don't need that anymore because there's no such thing as a standard bond. Get rid of it from here too in the bond C++ file. But what I need to differentiate between coupon rate of a fixed bond and market rate, the desired investment rate of an investor. So I'm going to have to put two rates in, and that will be the coupon rate, the fixed coupon rate of a bond, and that will be the desired market investment rate of an investor. So I'm going to have to do a few little changes here. The first one here is I'm going to have to make a couple of changes here. That's going to be the fixed coupon rate, pair of getters and setters, and I'll need a corresponding pair of market rate getters and setters. Okay, I think we're okay so far. Now, again, also, if I am going to have two sorts of rate, I'm going to need two variables to distinguish them. So the first one will be a coupon rate, fixed coupon rate of a bond, and the second thing will be the market rate or the investment rate for a particular bond. Okay, I think I'm happy with this file so far. Could be problems I've missed, but we'll figure all that out later. Okay, let's get on to the bond Cpp file. I've got rid of the basic bond constructor. I've now got two rates coming in, so double, I'll call that coup, and I'll call that market, and I think that will do for now. Does that look okay? That looks okay, doesn't it? Let's not worry too much about that. So I've got 5 things coming in now. Obviously I'll need to set, this isn't set rate anymore, this is now set coupon rate, and this is coop. Also as well, I really ought to remove output messages inside these constructors. It's not very nice practice, so let's not keep going with that anymore. So set market rate, and we'll set this to MKT, there we are, which is the market rate coming in. Now, I do have to, we've got the 42 there, we'll sort that out at the end of this lesson. I think we're okay most of the way down here. The problem is, of course, are these rate things here. So I shall conquer and divide here. Now, this is going to be set to coupon rate. This will be coupon rate. This is get coupon rate, so return coupon rate. Same thing down here, but for markets. Markets rate is that. Notice it doesn't matter what we call these. Just make sure it's different from anything else. And get market rate and return market rate. Okay, I think so far I'm happy with this. Oh, what was the problem there? Turn market out. Little m. I think this is all right. Anything else we need to do? I don't think so. I think we're all good to go with these things now. I just need to bring this across again. Let's have a look then at the main program. Now this is probably going to, oh, I need to put the extra rate in here as well. So the coupon rate is 10% and the investor wants 10%. This is going to return a price of 42, I know, but we'll sort that out very shortly. Okay, now before we move on, just want to make a little point here. Look how small the main program now is. Isn't that beautiful? Because all of our hard work is being done inside the bond class. All we do is say, give me a bond. It gives you a key. Make it a red bond. Make it a 5-litre engine. Make it, don't know, heated rear windscreen, whatever. And then use the key returned to start the engine and get the price. This is now much cleaner and much simpler in the main program. So you as the designer and developer, if you've got a nice bond package from your quant department, you don't need to worry about how it works. You just need to trust that they know how it works. And as long as they give you the interface, then you can just get the price out nice and easy. So when I buy a car, I don't need to know how to fix it. I just go to Mercedes, they give me a car, they give me a car, they give me a car key, and I drive away. I don't need to know how it works. That's all taken care of in here. So that's good so far. Now what I need to do is write a much better get bond price routine, because something that always returns a price of 42 isn't really going to cut the mustard. So let's get back to the bond CPP program and get some better output going from here. Okay, really this isn't, it isn't that hot, is it really, at the moment? Just return 42. Not the greatest program in the world. Okay, let's kick off then. Let's set up a variable we're going to return. Now we could just return a calculation, but let's do it explicitly in full. Set a bond price up, set it equal to 0, and then later on return that variable. Return the bond price. So now I should be getting price of 0. There we go. Now there is a little thing we need to worry about. This is payment type. Is it an annually paying bond? Is it a quarterly paying bond? Is it a semi-annually paying bond? What kind of a bond is it? And that's going to affect my calculation, so I need to take account of that. The first thing I need to do is I need to say, right, I'm going to set up a thing called a scaling factor. And I'm going to do a little check on the scaling factor. So the scaling factor coming in is I'll get the payment type, which will be an A, an S or a Q, and I will see, is it equal to, let's find my little file, is it equal to this chap here? And if it is, then set the scaling factor to 1, because it's an annually paying bond, so set the scaling factor to 1. So is it equal to that, which is an A? If it is, set the scaling factor, which I've just set up, to be equal to 1. I know that's more hard coding. Those who are keen and for homework can figure out how to have that not be a 1. So that's a nice little bit of homework for you later. Now here's a new thing we haven't seen before. Before we might have just left the if statement and said if something then do something, or don't do anything. Or we might have had an else, otherwise do something else. But now we're going to have an else if. Now you could use a thing called a case statement here, but I loathe and despise case statements personally, so I'm going to let you find out about them yourself, because they've always given me problems in the past. So I much prefer to use else ifs. I want the semi-annual type. There we go. And if I get a semi-annual type, I'll set the scaling factor to 2. We'll see how we're going to use that later on. Basically, we're going to halve interest rates and we're going to double periods. Very similarly, we're going to say if the payment type is equal to bond quarterly type, we're going to set the scaling factor equal to 4. So if it's an annual bond, set it to 1. If it's a semi-annual bond, set it to 2. If it's a quarterly bond, set it to 4. Hopefully that's sort of making some kind of sense. Now what I need to do is work out the fixed coupon that's coming from the bond. So I'm going to put that into a variable. And I'm going to say that that's equal to the principal payment, which could be $1,000, multiplied by the coupon rate divided by the scaling factor. So if it's a 10% bond, 10% advertised bond, $1,000, I should get $100 a year. But if it's semi-annual, then that's not going to be $100 a year, it's going to be $50 a year. So $100 a year divided by 2 will be $50 every 6 months. Sorry, that'll be the rate. So it'll be 5% every 6 months multiplied by the 1,000 to give us $50. So we work out the individual coupon payments. Hopefully that all makes sense. Let's just check my main program. I'll just put a few, 10%. But semi-annual, so it should be $50 a payment. Let's just check it is. So see out coupon. Let's give it a whiz. Is it $50? Lovely, it's $50. And again, if I make it an annual coupon, should come out as $100, 10% on $1,000. And if I make it quarterly, should come out as, was that 25? But I'll stick with semi-annual because that's the kind of vanilla standard bond. Okay, let's move on, keep moving. So how many periods do we have to go? Now we have 10 years to go, but we're semi-annual, so I really have 20 periods to go. So what I'll need to do then is I'll need to have another variable, and this is going to be the number of years to maturity multiplied by the scaling factor. So if the scaling factor is if the scaling factor is 2 and there's 10 years to go, then the number of periods, number of payments to make will be 20. So again, we'll just check that. This should come out as 20. Let's give that a whiz. So it comes out as 20, lovely, good stuff. Okay, now I need the investor yield. Again, semi-annually this is going to be halved. Quarterly it'll be quartered. If it's annual it'll just be the same as what we inputted. We always input annual rates for everything, so otherwise we'll get completely confused. But we need the kind of yield rate per period. So this is going to be a double of yield equals get the market rate. And that's going to be, is that divided or multiplied? I can't remember. Oh, it's divided, of course, sorry. Lost my thread there for a moment. And let's just check that. That should be coming back at, what did we say? The main program. 10%, so that should be coming back at 5%. So let's just check that to protect the innocent. Now, for homework, you could put all this entire subroutine on one line if you like, with as few variables as possible. But I'll let you do that for homework. Now, got everything I think we need. We've got a lot of coupons coming in. We've got 20 coupons coming in, each of $50. What we need to do is present value those things. I mean, if you think of it like this, here's me now, and then I've got a payment in 6 months' time, and I've got another payment, I've got another payment, I've got another payment. Looking out into the future, payment, payment. Oh, sorry, I should have used C for this, shouldn't I? Payment, payment. Oh, I've just jumped in time there, etc., etc., etc. What I need to do then is I need to present value all of those payments. I need to present value all of those payments back to today using my desired interest rate. I won't do them all, I'll just do the first 3. And when I've got all of those, I need to add them together to give me a sum that all of those P's are worth together. So if I get $50 in 6 months, that's worth more than $50 in a year's time, which is worth more than $50 in 18 months, which is worth much more than $50 in 10 years' time. So I present value all of the payments over time using my given investment rate. I present value them back to today. I add up all the numbers, and I come to a single value for all of those cash flows. So let's do that now. We'll call that PV coupons, and that's equal to, oh, I haven't created a value there, so double PV coupons, and that's going to be equal to, you can work this out yourself later, it's just a little formula that's fairly standard. 1 minus the power of 1 plus the yield. Oh, did I type out the yield? Oh, we'll check the yield in a minute. And then that is raise to the power of minus the number of periods. And then we divide, oh, sorry, I've missed wrong thing there. Okay, let's just check those brackets. That looks right, that looks right, that looks right, and then we divide that by the yield again. And that should give us, yeah, got to include CMath, so let's just include CMath to get hold of the power function. Not used, okay, no problem. So let's just output that. What should this be? 50 times 10, it should be, sorry, times 20. If we don't worry about present valuing this, so just do a field equation on the fly. $100 here, worth just a bit less than 1,000, shouldn't it? present value for coupons. It'll be a bit less than 1,000, I hope. Yeah, that's well, quite a lot less. I'm just going to trust that. That sounds about right. If it come out as 6.23, I would have been a bit worried, or 6,000, I would have been a bit worried. That works for me. Okay, so I've got the coupon. What I haven't got, though, I've got all these coupon payments, which actually, what I'll do is I will change all of these to C's, because P generally stands for principal, isn't it? What I haven't worked out so far is if the company that's issued this bond doesn't go bust, or the government that's issued this bond doesn't go bust and can't print the money that it owes to you, then what I need to do, what I'll be expecting is after the 10-year period, I'll also be expecting a big payment. Now that'll be the last lump sum, so this will be the $1,000, so we'll just forget about this for the moment. We'll just put some year markers in there instead, because I'm not worried about those at the moment. And what I need to do, because I've already calculated those, what I need to do is I need to calculate what that P's worth. So forget about coupons. What I need to do is I need to calculate what that P is worth. So it's not added anything together, it's equal to some value that's been present value. So if I get $5,000 or $10,000 or 18, if I get $1,000 in 10 years time at a certain interest rate, what's it worth to me in the hand today? Again, it's going to be worth less than 1,000. Let's just work out exactly how much less. So I need to, what's the present value of the redemption sum? And that's going to be equal to we get the principal first of all, which will be in my case $1,000, and then we multiply that by the power of 1 plus the yield, raise the power of minus periods, and that should give me a number a bit less than 1,000. It'll be a bit less than the previous 623, I should think, because that includes some payments we might be getting in 6 months' time. So let's, what's wrong with that? Oh, power. I shouldn't use power, should I? Use pow. And I need to see out that, don't I? So we can just do a bit of a sanity check on it. PV of redemption or maturity value, or redemption value, assuming the company has lasted that long. Let's give it a whiz. A bit less than 623. Yeah, well, a lot less than 623, because remember, with the coupons we're getting payments every 6 months, 1 year, 18 months, 2 years. With that $1,000 at the end, we're just getting it in 10 years time, and that's it. So quite a fair bit less. Now, to get the price of the bond, it's this added to this. Nice and easy. So I could just return that. I could return PV coupons plus PV redemption, but it's a bit unclean, I think, for the moment. But so what I'll do is I'll say bond price is equal to that plus that, return bond price. I'll also as well just say internally, what do I think it's worth internally, just as a sanity check again. So internally, internal bond price, make sure I'm getting the right output at the other end. Oh, what happened there? That was a bit hairy. So what's that going to come? What's that, about $1,000? So it's 1,000. Well, seems a bit coincidental, doesn't it? But think about it. Should be, shouldn't it? The coupon rate is 10% and the desired investment rate is 10%. Well, it ought to be 1,000, and that's actually a good sanity check that the program has worked. If we said that the investor wants 12%, then the price should be lower because the bond's not paying enough, so the price should be lower, giving us a discount bond. And if the person's getting 10% only wants 8%, then it should be a premium bond, should be higher than 1,000. So I think this is pretty good actually so far. So what we can do now is we can you can see there that get bond price is returning the price put in. Let's put something a bit more funky in there. $7,000 bond principal, returning 7%, 007. Oh, I've got it in. I managed to get it in. The person wants, what do they want? They want 13. No, let's not use 13. 14. Let's not use 14 too much like 7. 15%. And there's 12 years to go. And it's a semi-annual bond. What's it worth? $3,924. Why am I missing this bit of text? Why's that not coming out? Oh, it is coming out. What's coming out there? Oh, it's kind of getting itself in a bit of an output heap there. So what I'll do is I'll just say double external bond price, just to make the output a little bit nicer, equals this. All the output streams are getting mixed up. And then I'll output this. Should mean we get a nicer, cleaner output. So let's give that a go. That's better. So the class, the object itself internally, before it releases the figure, says, "Oh, this is what I'm about to send." And on the outside world, in the main program, which again you can see is still very, very short, it's getting back the right number, which is fantastic. Let's just check this. If they want 7%, it should be coming back as 7,000, shouldn't it? There we are. Oh, superstar. And if they want less than the coupon rate, it'd be more than 7,000. There we go. Now, I might not have written that calculation out perfectly. I might have done something wrong. I think it's pretty good. Just as a homework check for you again, you can go through that calculation and you can study the CFA and you can learn all these equations, and you can rewrite this yourself to write a much more perfect answer than I've given you. But hopefully, I think that is pretty good. I think that's pretty bang on, and I'm going to leave it there. Just a quick recap. We've cleaned up the header file. We've got rid of a bit of hard coding, not all the hard coding. There's no such thing as a standard bond, so we've got rid of the standard bond constructor. We've clarified what we mean by rate, and we've set up the appropriate functions and variables to deal with two different kinds of rate: the fixed rate of a bond and the desired investment rate of the investor. Inside here, we've got rid of the bond constructor, the simple one, and only left the more complicated one. We have written a pricing algorithm which hopefully is generating good results, and we've again added these extra set coupon rate and set market rate methods to enable us to use this bond class with confidence. I think that's enough. I'll see you next time.